Hi Calculus 1 students. So this is the last example in which I'm asking you to express something as a definite integral. Okay, so this relies on you on understanding what is the structure of a definite integral. So before we start, let's actually remind that. Okay, so just reminder. Okay, and this we will base our answer on this formula, right? The definite integral from a to b of a function, okay, is the limit, okay, as n is approaching infinity of, so we're gonna get the sum, okay, from from I equals 1 to n of f of xi times delta x, okay? Where xi can be taken as, like, remember, we have like left endpoints or right endpoints, but in general, we will take it to be right endpoints. Okay, so with that in mind, let's actually do it. So the first thing to notice in that definition is that delta x is actually not going to depend on I, right? So we can always take okay, delta x to be the length of the interval, so b minus a over n. But what I mean by this is that we can always take delta x to be a constant. Okay, and if that happens, it means that we can actually factor out the delta x out of the sum, not out of the limit, because delta x, as you can see, depends on n, but out of the sum. So what it means is, okay, we can say that the integral from a to b of f of x dx is going to be the limit as n is approaching infinity of delta x times the sum, okay, of f of xi. Why is this important? It's because that is how this is structured. So let's put a lot of color actually. Okay, so look, the limit, we don't have to like, this is the correspondence, right? The limit here corresponds to the limit that's over here. Something that is much more interesting to see is that this delta x right here corresponds to the 1 over n that is here. Okay, so what does it mean? It means that b minus a over n is equal to 1 over n, okay? And from there, you can deduce, obviously, that b minus a is equal to 1, okay? Now, don't forget that you have an ambiguity. You can choose what a is, and from what a is, this will determine what b is. But now let's have a look at this thing right here. This xi, okay? Remember that if we choose right endpoints, okay, so let's actually just write this down for now. And let's suppose that we choose right endpoints. So choosing right endpoints, okay, it gives us a very simple way to write xi. So xi is going to be a plus I times delta x, okay? And this is only true if we choose right endpoints, but that's what we'll do in order to make this simpler. Now, again, let's have a look at what could be f of xi, okay? So, for example, let's write x1, and I'll color code this in orange. So example, x1 is equal to a plus 1 delta x. And we have this over here. Now let's calculate what is a plus 1 delta x. we got here that delta x is 1 over n. Okay, so a plus 1 over n, which as you can see is equal to 1 over n. Like, to write this, don't forget that I'm basing myself on what's written over here. So I'm expecting this to be f of x1, okay? And this means that a is equal to 0. And from the previous step, okay, so because b minus a is equal to 1, so this like b minus a is equal to 1, I get that b is equal to 1. All right, now let's have a look at what is f of xi, okay? So let's call this step number 3, okay? So what's important is to kind of make a list, right? So f of x1, as you can see, this is x1 is the orange guy. So we have like x1 in here, okay? So that's going to be equal to the cube root. And then let's have a look. So here I forgot to put 1 here. That is actually important. Well, x1 is equal to 1 over n. So we're getting here the cube root of 1 over n. And we can easily check that this is the case also for, let's say, f of x2. Okay, so f of, and I'm going to choose another color. Which color could I choose? Let's say black for the time being. There you go. So this will be the black one. So f of x2. Now don't forget that f of x2, using this formula, it's going to be f of 0 plus 2 times 1 over n. And now you want to write that it's equal to this term. So it's going to be equal to the cube root of 2 over n, which matches exactly what we have here, okay? And it's fairly easy to check them all, but I think that this is convincing in the sense that we can write that f of x is equal the cube root of x. Okay, now let's see what do we need, right? So we have our delta x, which is not quite important. We have our function, and we need a and b. Okay, good. So let's focus. We got our function, we got our a, and we got our b. So meaning that the final answer, and let's actually erase this now, or no. Yeah, let's erase this. I wanna have the reminder because I'm gonna use it now. So it means that this limit this limit, or maybe I could just say here that the limit as n is approaching infinity of like this guy. Okay, so cube root of 1 over n, and then I'll skip some terms here. Okay, so this is equal the limit as n is approaching infinity of this. Remember, we saw was delta x. Okay, so this is our delta x. And then what we have is the sum, okay? And as you can see, we have like 1, 2, up to n. So it's going to be the sum from I equals 1 to n of, that's it, the square root, the square root of xi. So as a result, this will be the integral now from 0 to 1, right? So the 1 here, the 0 here, of this thing. So the cube root of x times dx. And this is it. This is our integral. I hope this helps. See you either in class or in the next video.